SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.
Hi, we are back. Good afternoon. Myself Sadrisha and my friend Neil Patel from IIT Bombay. So we all know each other by now, so let's get started. We just a quick recap. We have already seen Libre-Office, Mozilla Firefox installation and using Linux. So today let's start something new, right? But before I start the lecture, I sincerely apologize to few of the students because the software that we'll be starting today is pertaining specifically to the science students, because it is Scilab, as in Sci in science and lab in laboratory, Scilab. So the name itself contains science, so the commerce and art students out there may not be so much interested in the lecture. So just another way to tell you that if you're not interested, just shut off the screens and you can do your own work. But I again request you, and we welcome everybody who wants to view this lecture and learn new softwares every day. So Scilab will start. Now why Scilab? I told you Scilab is Sci as in science and lab as in laboratory. Combine two words and it becomes Scilab. Again, as you know, it is of course free and open source software. Scilab, it is a free and open source counterpart for MATLAB. MATLAB is matrix laboratory. Mat as in matrix, lab as in laboratory. So matrix laboratory, MATLAB. It is a licensed version costing quite exorbitant prices. So Scilab, complete similar to MATLAB, and it has all the features that MATLAB has. So why not use Scilab? Now Scilab, as you know, it gives you range of functionalities. You can start using Scilab as a simple calculator to writing very enormous and huge calculating examples, integration, differentiation, differential equations, anything, you name anything and Scilab has solution for that, right? But mathematical solutions for each and everything Scilab provides. So we use Scilab, and I told you it's a counterpart of MATLAB. It is basically very much useful in simulation. That is, if you want to plot graphs, if you want to analyze the graphs, Scilab comes to your help. It's free, open source, downloadable. So let's get started with installation of Scilab. Just have a look at the computer screen. I'll open my browser, and the website for Scilab is scilab.in, S-C-I-L-A-B, scilab.in. So Scilab.in is the official website of Scilab, and yeah, here we are, Scilab.in. This is a simple logo of Scilab, as you can see. Now, spoken tutorial is directly associated with Scilab.in initiative. It is an initiative for India. You can see over here, we have a link of spoken tutorial. Let me zoom it so you can see. Yeah, right over here, spoken tutorials. So we are directly associated with Scilab.in, and let's go to download. It's over here on the third from left. I'll click on downloads. New window will open for me, which will allow me to download Scilab. Yes, I'll zoom it so everybody of you can see. Yes, it is written the latest stable release of Scilab is 5.3.0. Of course, we'll use the latest stable version without a doubt. And let's see, you have it for Linux, for Windows, everything. We will use Windows right now. Okay, so for Windows, this one, it is again Scilab 5.3.0, 32 bits, 64 bits, but what is recommended? It's 32 bits is recommended. So we use Scilab 32 bits. I'll click on the link, and that will start my download for Scilab. It's big enough, about 108 MB. I already have Scilab downloaded in my computer, so I won't waste time downloading Scilab now. I'll close the window, and here I have Scilab installed. Actually my system is 64-bit, that's why I have downloaded 64-bit version of Scilab, but most of you can use 32-bit versions also. Okay, let's start installing. Double click. Yes. Select the language. Let me zoom so you can see. Select the setup language. Okay, I'll okay, welcome, click next. License agreement over here, we will accept the license agreement, right? I accept. Next, select full installation over here. There are many more. You can select full installation, and I'll click next, and next. Okay, now something really important before this. See, we did simply nothing, clicking next. It's very simple installation, but one point which we all should remember, that while installing Scilab, there is one library needed, which is called Intel Kernel Library, Intel Math Kernel Library, which will be downloaded online. And that is very important, that whenever you install Scilab, your internet has to be connected, otherwise it won't install successfully, right? For installing Scilab, internet connection mandatory. Okay, ready to install? See, it shows ready to install. I'll zoom it. Ready to install? Yes, I'm ready to install, and I'll click on install. See, it's showing me downloading Intel Math Kernel Library files for Scilab. It will take some time to download, but you see, speed is good enough over here, but it will take again few minutes, 6 to 7 minutes. And after this library is already downloaded, the Scilab will install automatically. No more steps required. So I'll just cancel this download over here, and we can start using Scilab. Cancel, yes. Okay. I'll exit the setup right now, and I have Scilab already installed. Let me open Scilab. Yeah, over here. Yeah, Scilab is started. See, for Scilab we need to fire some commands, and these commands are case sensitive. What does this case sensitive mean? I'll come to that slightly later, but let's get acquainted with the Scilab window. The usual options that we have: file, edit, preferences, control, applications, and help over here. Okay, now other all things like this is new, open, cut, copy, paste, save, etc., many other things. So this was a brief overview of Scilab windows, but actually we won't use these options much because everything we can do is with commands, right? So let's get started with simple commands. I will put it, yeah, I have zoomed it so that we all can see. Let's fire some very simple commands. I'll write 3 plus 5 and answer is 8, correct? I'll write 4 minus 3, answer is 1. Good enough, right? Simple calculations that we have done. So I hope you can understand how this can be done. Let's move on to some really complex calculations. Complex as in not mathematically complex, conceptually complex. I'll write 48, let's say, minus 4 into 4 plus 64 divided by 4. I'll write this. Okay, I'll just scroll and zoom in the windows. Okay, yeah, you can see. Now see, this is a very long calculations, so we all are aware that this calculation will be solved by Bodmas rule, right? BODMAS, bracket of division, multiplication, addition, subtraction. We all are aware of Bodmas rule. So this will be solved using Bodmas rule. So like, let's try it manually once. We have 4 into 4, so multiplication, and we have 64 divided by 4, division, which will be solved before addition or subtraction. So 64 divided by 4, that is 16. 4 into 4, again 16. Now addition and subtraction. 48 minus 16 plus 16. So answer has to be 48. Let's see. 48 It's expected. So Scilab knows the Bodmas rule also, right? Good enough? Okay. Some more functions, I'll just let you know. A quick recall. Let's do a square. 7 raised to 2. Now see, do you notice the raised to thing? It is a caret sign we usually use in vector theories, right? Caret. That you can type with shift 6 on your keyboard. That's a caret sign. Okay. 7 square 49. Answer there you have. Let's try with square root of 16. Square root function is sqrt in bracket 16. Enter. Answer is 4. Right. Now let's try some complex exponent functions. 17 raised to 0.3. Right. Your scientific calculator can do this. Manually you cannot. Answer is some like 2.3395, so on and so forth. Everything you can do. One more thing, let's try 34 raised to, in the bracket let me write 2 by 5. Alright, what is this actually? This is actually the fifth root of 34 square. Can I say that? Okay, 34 raised to 2 by 5. Answer is something 4.098 whatever. So now you know how you can get started with Scilab. Some basic commands we use: addition, subtraction, Bodmas rules, power, square root, and things like that. Now all these were natural numbers. Complex numbers. Complex is what? I. We write iota for complex. How does Scilab interpret iota? It is written as percentage I. A simple I cannot work, so we write percentage I. I hit enter. So answer is I. Did you see over here? Answer is I. Okay. Now I square, in complex numbers I square is minus 1. Let's try. How we write I? Percentage I raised to, I'll move the cursor. Oh, sorry. Yeah, percentage I raised to 2. Answer is minus 1. So the I that Scilab interprets is correct. Okay. Let's try one mathematical function with complex numbers. I'll write 10 plus 5 into I. Now just note the syntax. It's simply not 5I, it is 5 into percentage I. I will multiply it that with 2 into percentage I, that is, so this is actually 10 plus 5I multiplied by 2I. Answer minus 10 plus 20I, right? Mathematically, is it right? 10 into 2I, that is 20I that we got. 5I into 2I, that is 10I square, that is minus 10. So minus 10 plus 20I is the correct answer. So this is how we use complex numbers in Scilab. Next, pi, our mathematical constant pi. So that is percentage pi. 3.1415 whatever. Percentage pi gives you the value of pi 3.14 or 22 by 7. Where we normally use pi in trigonometric functions. Let's have one trigonometric function, sine. Percentage pi. Okay, sine pi. What is sine pi? 1.225d minus 16. Now this is something really clear. Okay, let me write pi by 2. Sine pi by 2. 1. Okay. Sine pi by 2 is 1. Yes, it is, right? Now what is cos percentage pi divided by 2? Cos pi by 2. Almost 0. See, let me tell you, this is something we got again, so I'll just explain it. It reads 6.123 d minus 17. Now what does this mean? See, the d, that is actually the power of 10. So this has to be read as 6.123 into 10 raised to minus 17. Clear? I repeat, 6.123 into 10 raised to minus 17. So that is approximately 0, right? We don't go to the 17th decimal place. It is 0. So many trigonometric functions you can explore: sine, cos, tan, cot, cosec, everything. Okay, so logarithms. So this is a quick review I am giving how to use Scilab. So by the end of today's class, I expect that we all are aware of how to use Scilab and how to fire functions. Now I said initially something about case sensitive. Scilab is case sensitive. I'll write, let's say, capital COS percentage pi divided by 2. I get an error. You read error. So if I write C capital, it is an error, but if I write C small, I get the answer. That means capital C and not capital C are not the same. The case, uppercase or lowercase, the case really matters for Scilab. It may not matter for many other languages, but for Scilab it does matter. So be very careful where to use capitals, where not to use capitals, where to use uppercase, where to use lowercase, but mostly the functions name, the trigonometric, logarithmic, matrix, all the functions name are in lowercase, right? Okay, so this was something I gave idea about case sensitive. Let's work with some logarithmic functions. Okay, so E, what is E? The natural logarithmic constant, exponential constant. What is that? 2.718, correct? E, the exponent we normally use. So how to write E? Again, percentage E. You see, the constant and the numbers, we precede them by percentage. Percentage I, percentage pi, that is pi, percentage E. So this is important. Don't forget percentage, else you may get an error. So E is 2.718 recurring. Okay, now we have exponent function also, exp 1. It will also give me 2.7.